So we've seen access control lists, we've seen object groups, but up until now we've been using static routing, which probably isn't quite realistic in a real life network scenario, as we'd probably be using a dynamic routing protocol. And there are a couple of the dynamic routing protocols that I will cover in this section. So let's have a look at our topology. So I think that we're going to, between the inside router and the CLI firewall, we'll use EIGRP. Then in this middle section between the CLI router, the DMZ and the ASDM firewall, we will use OSPF. And then between the ASDM firewall and the outside network, we're going to use BGP, external BGP. Now, what I've done in the meantime, I've removed the static routing. So from our inside network, if I jump onto our inside network, we shouldn't have reachability any longer to any of the loopbacks on the outside network. So let's do a ping 143.12.0.1. Yeah. And I'm sure there'll be some other things that will trip us up on along the way, but I don't write out all of these things. I try and do live troubleshooting because in a network, I'm not going to have it all scripted out. I will have to do live troubleshooting. So I'm trying my best to try and replicate as close as possible a real life scenario, which it isn't a real life scenario, we know that, but I'll try to replicate a real life scenario and how I would go about the troubleshooting process if any issues come up. Okay, so by the time I finish this, we should be able to see EIGRP in action, we should see OSPF in action, BGP in action, and as this is a security based course, I will do authentication between the links, and the end goal should be that I have reachability from the higher security level, which is the inside network, all the way across to the outside network loopback addresses. That's the aim of it. So I've removed all the static routes, and by the time I've finished, I will have 3 routing protocols. I will have to do some kind of redistribution between those protocols, mutual redistribution, to get full reachability from our inside network, which is here, all the way over to these loopbacks. So let's go. So I said the first thing, let's have a look at what protocols are running on our inside router. Show IP protocols. Come on. Show IP protocols. We've only got the application. So the first thing I'm going to do is enable EIGRP. If I say router EIGRP 100, we're going to say no auto summarization. And then we're going to advertise our loopback and our directly connected IP address. So if I say network 192.168.10.2, now I want to show you something here. You're supposed to use a wildcard mask on the routers to advertise this, but if I just put a normal mask 255.255.255.0, you see that the router has actually taken that. Let me do the next one as well. Network 30.1.1.1 255.255.255.255/32. It has taken that. But if I was to actually go and look in the configuration on the router itself, can you see that it was intelligent enough to inverse the mask? And here, because 192.168.10 is a class 4 network, it didn't even add the /24 mask because that is what it is automatically. But what I was trying to show you is even though I added in 255, 255, 255, 255, and it should be a wildcard mask, it actually converted it to a wildcard mask automatically. Just a little trick that I've noticed throughout the years. All right, so that is my EIGRP configuration. Oh, and I also need to do a keychain because I'm going to authenticate the links. So if I say, and only need to do a keychain for EIGRP, none of the other protocols. So if I say keychain, router coach chain, we're going to use the first key, key 1, and we're going to add a key string, which is like a password of router coach. And then we're going to apply it to the interface that we are connected to our CLI firewall. So that interface is here. If I say interface IP authentication mode for EIGRP 100, what are the options? MD5. Okay, so we'll use MD5. And then we say IP authentication. Let's use the keychain for EIGRP 100, and that keychain is our RC chain. I think that is it. Let's save that configuration here. And now let's do the same on our CLI firewall. So router EIGRP 100, no auto summary. And the network that we're going to advertise is 192.168.10.1. Now let's see what happens if we put a wildcard mask in here. Because it's opposite on the firewalls. You're supposed to put a normal mask, and on the routers you're supposed to put a wildcard mask. And you see it says invalid mask, it's discontiguous. So let's reverse that and put in a /24. And you can see that it's taken that. All right, and if I do a show name if, just to see. So our inside network is gigabyte 0/0, interface G0/0, and it's similar but not quite the same on the ASA. So what I need to do is say authentication mode EIGRP 100 MD5, and then I say authentication, what's the next part? Authentication key for EIGRP 100 is router coach. That's our password. And we're going to use our key ID of 1. And this key ID is which keys, because you could put multiple keys and time based. So it will be like they will rotate, are using key 1 or key 2, key 3, so on. All right, we should actually see on our inside network an adjacency, which we do here. So we see our neighbor 192.168.10.1 is up with a new adjacency. Now, if we were to jump onto our firewall, we should actually see that route. So if I was to say show route, and this D means that we have a route to the inside router's loopback, and we should be able to ping that. Ping 30.1.1.1. And obviously this wouldn't have worked unless we put in the authentication. So that looks like EIGRP is sorted. Now I'm on this same router. Let's do our OSPF configuration. And OSPF is going from our CLI, including our DMZ, and then the DMZ will have a link back with authentication to our CLI router and CLI firewall, and also to our ASDM firewall. So on this, I will say router OSPF 1. We're going to put in router IDs actually. So this router ID, I'm going to say, it could be a random. It doesn't need to actually be an IP address on the actual router. I'm just going to say this is 15.0.0.2. I'm saying it's 2 because it's the second device along. So this will be .2, this will be .3, and this will be .4 for the router ID for OSPF. The network we're going to advertise is 10.1.1.1. Our mask 255.255.255.0, and it's going to be in area 0. Now we need to do also our interface authentication. So for interface G0/1, I'm going to say, is it? So let me just see, make sure again. Show name if. Yeah, it's going to be on our DMZ. So for interface G0/1, I will say OSPF authentication. I need to just question mark to see what it is. It's going to be message digest, and our OSPF message digest key will be 1, and we're going to use MD5, and we're going to add our password, which is still going to keep it the same as router coach. Key 1 already exists. All right, so if I say show key, how do I see the keychain? So let me just say show run interface G0/1. All right, so it looks like I've already put that there previously maybe. So OSPF message digest key 1 MD5. Let me delete that and then add it again. I wonder if it will allow me to just delete it like this. Maybe the, okay, let's try that. And then add this again. Control A to go to the front of the line. Get rid of the no. All right, so that is our OSPF configuration on our firewall. Let's just check that. If I say show run router OSPF and show run interface G0/1, yeah, let's save that. Let's jump onto our DMZ and do the same. Do show IP protocols. We don't have OSPF running here, so router OSPF1. Do show IP interface brief just to make sure I know which interface I'm doing it for. It will be for G0/1. So router OSPF1. Now this DMZ router will only be running OSPF, so I could probably do, no, I won't do that. I was going to say I will do a 000 network, but I won't do that. So router OSPF for network 10.1.1. What I could do is 10.1.0.0, 255.255.0.0. That will be in area 0. That will cover both of those networks. I could actually add the loop back as well, but I will not. So what I will do now is interface G0/1 IP OSPF. No, is it IP OSPF? I think it is. Let me see. IP OSPF authentication. We'll keep that as message digest. And then I'll say IP OSPF message digest key of 1 is MD5 router coach. It said no valid authentication saying it is on interface gigabit G011. Is that what I done? Okay. Do show run interface G0/1. It's come up. Alright, and I need to do the same on interface G0/2. So I could just up arrow. And obviously it won't come up on the other side because I haven't done it on our ASDM. Let me just save that config and then check our OSPF neighborship. Do show IP OSPF neighbor. Yeah, that's come up. Excellent. Guys, I have a request from you. If you're enjoying the free content, I'm looking to increase my subscriber count to 4,000 subscribers by June. But I can only do that if you give me the Play Special. Do you want to know what the Play Special is? Press like and yeah, subscribe. Okay, back to the video. I didn't do a router ID, so let me... Okay, it doesn't matter about that. Right, let's now do the OSPF configuration on the ASDM. So I have our ASDM open here. Now to get into the OSPF configuration, we're going to routing, OSPF. First we're going to set it up. So let's set up OSPF first. So are we going to enable OSPF? Yes. Our process ID will be process 1. That's first. Now our area. Let's add that. If we click add. So for process 1, it will be under area 0. It's going to be a normal area. And the IP address that I'm going to add, it will be 10.1.2.0 on a /24. Let's add that. Now you can see that we could do area authentication, but I don't want that. I want interface authentication. So I will say okay on this. Then I will go down to interface. I will look at our DMZ. It is our actual DMZ interface that I'm looking at. It already says MD5, so let's see what's there. We've got MD5. We want to delete this key because that's no longer the key that we're going to be using. So MD5. Now, if we were going to be use this authentication, this is for plain text authentication, which we don't want. We're going to be using an MD5 key of 1, and our password, which is our MD5 key, is now router coach. Let's add that. Okay. And I press apply. And this is what it's going to actually send to the CLI. But I don't see where the interface is. So let's cancel that. Let's do this edit again and see. No, it hasn't. So what I'm going to do, I'm going to change it to password authentication. Delete this. Press OK. Let's just put in a fake password then. RC. This is anything. I'm going to check it. I'm not going to commit this anyway. Let's say OK. Now you can see that it's changed to plain text password, but I don't want that. I'm going to go back into edit. I'm going to change this to MD5. I'm going to get rid of these passwords. Now I'm going to try to put in our MD5 key of 1 and our password again, which is router coach. I'm going to add this, press OK, Press apply and see if it sends it this time. Yes, that's much better. So I've got router OSPF 1. It's in area 0. Our network is 10.1.2.0 on a /24 advertising to area 0. It's removed OSPF message digest key of 10 and it's added our OSPF message digest key of 1 with our new password of router coach. I'm going to send that to the CLI. I'm going to save that as well. And then I'm going to see if our neighbors have come up. I don't actually know how to do that here from the ASDM. Let's have a look. Is it in tools? All right, I'm just going to go across. All right, what I will do, I'm just going to have a look at it on our DMZ router. So do show IP OSPF neighbors. I should see 2 of them. Yeah, I do. So this is our ASDM. And this is our CLI firewalls. So far we've done EIGRP configuration and we've done our OSPF configuration. Now I'm going to do the BGP configuration, and here I'm already here on the, no I'm not. Let me jump onto the ASDM. So let's close down OSPF and go down to BGP. Start off with general. Enable BGP routing is what I want to do, yeah. Our AS number here, I'm going to give this an AS number of 100. I'm not going to use dot notation. Is there anything else I want here? All right, let's apply that. All we've got is router BGP. That's not enough. So let's see if we can add anything under that IP version 4 family. So for IP version 4, I want to add some neighbor. So our neighbor will be, let's add our neighbor. And our neighbor is going to be our outside network. So our neighbor is 209.10.12.2. The remote AS is going to be 200. I don't need a description. We're going to enable the address family, yes. Anything else? Filtering, routes, timers, advanced. Let's have a look at the advanced option and see if there's anything there. We want to enable authentication. So let's enable authentication. I'm going to put an encryption type of 5. And our password is going to be router coach. And we're going to confirm that password, which is router coach. Send community, use ASA as next hop, that will be next hop self. I don't think there's anything else I need here, but there's one more thing I need here, which is I want to add I don't need to add the networks here. I will be adding the networks on the outside interface. Outside router, let's press apply here. That looks better. So router BGP, address family IP version 4, a neighbor is in remote AS 200, and we have MD5. This is actually MD5 password. Let's send that. I will save it. I think that's it for our initial configuration. Now I need to jump onto our outside router. So for our outside router, and I'm only going to advertise our 3 of the loopbacks, so 143.12.0.1, 143.12.0.2, and 143.12.0.3. So let me say router BGP 200, neighbor is going to be 209.10.12.1, and that is in remote AS of 100. And the networks that we're going to advertise are 143.12.0.1 with a mask of 32/32. I would have expected the neighborship to, there's a reason why the neighbor hasn't come up, because I have authentication. So let me say .3, and let me go back to this neighbor command, and I will say password 5 is going to be router coach, and I expect that neighborship to come up. There we go. Neighbors up, and to verify that, if I do show IP BGP summary, and we can see that the neighbor's been up for 10 seconds. Let me save that. Okay, and now let me look at if we could ping that from our ASDM. So if I jump into tools and say ping, and I want to ping those loopbacks, any one of them. So if I just choose 143.12.0.2, let's see if we can ping. And we are able to ping. So the first half of our task is done. We've enabled EIGRP with interface authentication, OSPF with interface authentication, and BGP with interface authentication. However, we have a second part which is probably harder than the first, and that's to enable our inside interface, our inside router, to get access to these three loopbacks: 143.12.0.1, 143.12.0.2, and 143.12.0.3. And the only way that I could achieve that without static routing is by doing redistribution. And the redistribution points will be on the two firewalls. So let's try it on the CLI first. And I will have to do mutual redistribution, because if I do it on just one side, it will get the routes, but it won't have reachability because the other protocol won't have a route back. So on our CLI, the first thing I want to do is router. First, let's see if we can ping from the inside network. That's probably a good test. So from our inside network, can I ping 143.12.0.1? Obviously, the answer is no. After I do this first redistribution, I should be able to ping this DMZ router. So let's see if I can ping that. Ping 10.1.1.2, which I cannot. All right, so let's do that first configuration. Router EIGRP 100. Now the first part that I'm going to do, I'm going to redistribute the OSPF routes into EIGRP. But EIGRP and OSPF use different algorithms to calculate their routes. When we're redistributing OSPF into EIGRP, we need a way of translating that metric to something that EIGRP understands. Otherwise, the redistribution isn't going to work. Now, EIGRP uses 5 metrics, and these are bandwidth, delay, reliability, load, and MTU. So we're going to add those into our configuration when we do the redistribution of OSPF routes into EIGRP. So what I'm going to say is redistribute OSPF 1, and this is where we're going to use our metric. So our metric, I'm just going to put 1 for bandwidth, 1 for delay, 1 for reliability, 1 for load, and 1 for MTU. That is our first part. Now what I'm expecting to see is some external EIGRP routes on our inside router. So if I say show IP route, and here we see them, D, which is EIGRP, but external. But we still won't have reachability because this will have a route to the OSPF, but OSPF doesn't have a route to the EIGRP process. Just to prove that, let's say ping 10.1.1.2, still not pingable. So let's do it on the OSPF side, not on the DMZ router, I want it on the CLI. So for router OSPF 1, redistribute EIGRP 100. I think I need to put the subnets, and all this subnets keyword is this tells the OSPF to redistribute all subnet routes. Otherwise, only networks that aren't subnetted will be redistributed. And what that means is basically if you had like some loopbacks that had, or some other networks that had 10.11.12.1/28 and the other one was 10.5.0.15/16. Well, OSPF isn't going to do those subnets. It's going to say, listen, I've got a route to 10.0.0.0/8. Now, if they branch off to different devices or different networks, it's going to cause you a whole world of pain. So the best thing is just to put the subnets command on the end. Let's put that there, and let me look at the DMZ and see if it's got a route back. Do show IP route. And now we see that we have some OSPF E2 route. So theoretically, our inside router should now be able to ping the DMZ, which it can. All right, can it ping all the way across to the firewall on the other side, which is our ASDM firewall, which is 10.1.2.1. Yes. All right, so that's good from our side. Now let's try and do that on the ASDM. So on our ASDM, I'm going to run into, first, I'm going to redistribute in from BGP into OSPF. So I need to go under the OSPF. We say redistribution. We're going to add. Where's it coming from? BGP. I'm not going to change any of the metrics. I could give it a metric value of 15, let's say, for an example. I think the default is 20 because it will be an external route. Actually, let's just take that out and have a look. Let's say okay. Let's apply that and see what we've got. Redistribute BGP 100. I think we also need, for OSPF we also need to do the connected routes, because by default it doesn't add the connected routes. So let me cancel that and add another one, and also say connected for our connected routes, and use subnets. Let's apply that. Redistribute connected subnets and redistribute BGP 100. Let's send that to the command line. Only classful networks will be redistributed. So under the BGP, I also need to edit that and say subnets. So BGP, use subnets. Let's apply that because it didn't like it. Let's see if it likes it now. Seems like it liked it a lot better. So that's OSPF, and let's look at our BGP and do the same thing. So for redistribution, let's add. Source protocol is OSPF. The process ID is 1. The metric could be 35. We want internal routes, and we also want, if I jump onto, I need to actually open up the ASDM command line just to check what routes are they EX2 routes? I think it will be E2 routes. Okay, this is what we want, E2 routes. So let me jump back onto the ASDM and say internal, which we don't actually have any internal routes, and external 2 routes. Okay, let's apply that. So if you were doing this on the command line on the ASA, it would say router BGP, and under the address family of IP version 4, we say redistribute OSPF with the processor 1. It's going to have a metric of 35, and we're going to match internal OSPF routes, which are just O routes, and external type 2 OSPF routes, which is exactly what I'm looking for. Let me send that, and let me save that config. Now what I'm expecting, I will do it step by step. I'm expecting now on our DMZ, we should be able to ping those 143 routes. So let's see if we've got them first. Do show IP route. So we now have the 143.12.0.1 routes. Are we able to ping them? Do ping 143.12.0.1. Yes, I am able to ping. Am I able to ping this route, which is the inside route? I shouldn't be able to ping because I'm coming from a lower security level to a higher one. So let's see, do ping 30.1.1.1. No, that's expected. All right, so this is the big test. Am I able to ping? Let's look at our diagram again. Am I able to ping from our inside network all the way to 143.12.0.1 from a higher security level to a lower one? Let's have a look. Ping 143.12.0.1, and I have full reachability. .2 and .3. Alright guys, that's it for dynamic routing. I hope you've learned something, and I'll see you in the next set of videos.